As we continue our look at lines, we're going to talk in this video about the slope-intercept form of the equation of a line. Specifically, our objective, given the slope-intercept form of the equation of a line, graph the line. So, what do we know thus far? Well, we know what slope is. Slope is how steep a line is. It's also the average rate of change, which we're going to look at in more detail in the next video. It's a fraction, always a fraction, and keep that in mind. If it's not written as a fraction, you can write it as a fraction because slope is a fraction. It's a fraction equal to the change in the height divided by the change in the horizontal distance. Change in height is a change in the y values. Change in horizontal distance is a change in the x values. So the change in the height, or the change in the y, divided by the change in the x, or the change in the horizontal distance. And we also know that in mathematics, the slope is represented by the letter m. Okay, so a line, the equation of a line can be written in a variety of forms, or I should say the equation of a line can be written in a variety of forms. We're going to focus on the slope-intercept form of the equation of a line, and that form is y is equal to mx plus b, where m is the slope and b is the y-intercept. Hence the reason it's called the slope-intercept form, because you're given the slope and you're given the y-intercept. Okay, so how do we graph a line that is in slope-intercept form? Well, it's fairly straightforward. We want to begin by plotting the point that contains the y-intercept on the y-axis. So we know the y-intercept, we want to put that point on the y-axis. And then we're going to use the slope. Again, written in fraction form. If it's not a fraction, when you see it, you're going to want to write it as a fraction, because we're going to use that to obtain a second point. All we need are 2 points to make a line, so the slope will take us from the first point, which is on the y-axis, to a second point. Now, I've mentioned this previously. I tend to attach the slope sign to the y value. So I'll first rise or fall. If the slope is positive, I'll rise. If the slope is negative, I'll fall. And then I always run to the right. It seems to keep things simpler. And then finally, as you might imagine, you have 2 points. So connect the 2 points with a straight edge, or I'll do my best with my hand for this video. Let's take a look at 2 examples of graphing lines that are in slope-intercept form. Okay, example 1 here. Graph the line given by the equation y equals 2/3 x minus 1. Well, we know this is in slope-intercept form. Y equals mx plus b. This could be plus negative 1. So our slope is equal to 2/3. And our y-intercept is equal to negative 1. Again, because we can write this as 2/3 x plus negative 1, if you want to see it. Y equals mx plus b. So the b is negative 1 right there. Okay, let's sketch it. We don't need to be, again, I'm not going to be overly fancy with my sketch. Just give you a sense of what's going on. Okay, it tells us we want to start with the y-intercept. We know a point. The point is the y-intercept at negative 1, which is 0, negative 1. I'll put my negative 1 right there, and there is the y-intercept. Y-intercept, as a point, it's 0, negative 1. Now we're going to use the slope to find a second point. This slope is positive, and so I'm going to put my positive with the number 2, the numerator, because I'm going to rise 2 before I run to the right. So rise 2, 1, 2. So here is the rise 2. And I'm going to run 3. 1, 2, 3. Okay, so here is the run 3. The slope positive 2/3, go up 2, go over to the right 3, and put a point. As you can see, that point is the point, whoops, I got it backwards. It's not the point 1,3, it's the point 3,1. It's the point 3,1. So I started with the y-intercept. I used the slope to come up with a second point. And now all I have to do is, again, sometimes I miss. I probably should use a straight edge. Is connect the 2 points. And this is the line given by the equation y is equal to 2/3 x minus 1. This is the line. This is its name in slope-intercept form. It's the slope-intercept form of the equation. Its name is y equals 2/3 x minus 1. Let's do a second example where we have a slope that is not immediately written as a fraction. Graph the linear function. We know the same thing. Linear function is telling us, because of the root line, that we're graphing a line with an average rate of change. Okay, well, we know from our definition that average rate of change is telling us this is the slope, the average rate of change. The average rate of change in example 2 here is -2, and the y-intercept is 3. Okay, so our slope is saying it's -2. Well, that's not a fraction, and slope is a fraction. So we can make this a fraction by putting it over the number 1. And again, I like to keep the sign with the numerator. It's the same thing as as -2 over 1, but this tells me I'm going to fall 2 before I run to the right 1. So the slope is negative, go down 2, and then run 1. Okay, we know our y-intercept is equal to 3. Okay, so we took this slope, which was not given to, first off, it was not given to us named slope, it was given to us named average rate of change. We know that mean slope. We were given an integer, not a fraction, and I simply wrote that over 1 to make it a fraction because slope is a fraction. Rise, change in y over change in x, rise or fall over run. Okay, let's go ahead and sketch this line. Once again, nothing fancy. The y-intercept is +3, so I will go up to 3, and I'll put a point. And again, this point is at the point 0, 3. That's our y-intercept. Okay, crosses the y-axis at 3, which means its x value is 0. Our slope is negative. Go down 2, run 1. Okay, down 2. So there's my change in my y. I went down 2, and then I'm going to run 1 and put a second point. This second point turns out to be the point 1, 1. Okay, so I went down 2, and I always run to the right. And so here's the slope, down 2 over 1. I have 2 points. So I'll connect these 2 points with a virtual, straight edge. And there is the line that was graphed. And this line, well, we can give the name of this line. Y is equal to the slope, -2, times x plus the y-intercept, which is 3. Okay, that's what it's going to look like. Now we want to remember this is the same thing as y is equal to -2 over 1 times x plus 3, which is what we wanted to use. We wanted to come up with graphing the line.